In this video, we'll be looking at the Introduction to Statistics Unit 1 Practice Exam Solutions. To get started, we'll be looking at calculator input and doing things by hand as well, but it'll be handy to have your calculator with you throughout this video. To get started with our first question, the directions are really up above here where it says find the mean. So here we are to find the average of these values. The best thing to probably do here is to input this into your calculator under L1 for list 1. So let's go ahead and pop up our calculator and input these values into list 1. So we'd go to Stat, and then we want to go to Edit, so that would be choice 1. Now I already have values in L1 and L2, so I need to clear mine. If you have values in there as well, you'll want to make sure that you clear those. So you'd go up to the title and hit clear and enter, or you can do clear list from the screen before. And now what we'll do is we'll enter all of these values. So we start with the 227.64, hit enter, and then enter all the values. Now be really careful about how you enter these, even if you're off by a decimal or a single value. That can affect what's going on here. I'm going to pause the video for a moment while I enter all of these values, and you guys go ahead and do the same on your calculators. Okay, I have all of my values entered. Now if we count these, we have 9 values. Also, you can tell toward the end we're having our list 1. This means element 1, our first one. So if we scroll down, it counts for us. And you can see that we have 9 values entered, and we have 9 values over here on the right. Now to come up with your summary statistics for here, we would go back to Stat, Calc, 1 variable statistics, my first option. And everything I have is in L1. Now if you don't have L1 listed, you would go to second, and then L1 is above the number 1. Your frequency list should be blank because we don't have a frequency list here because they're all just occurring one time. And then we can scroll down here to calculate and hit enter. Now if you don't get this screen and you just get 1 var stats, then you would have to input L1 into the screen. So we'll hit enter here. We can see our solution for X bar is 260.83. And if we scroll over here, we can see that 260.83 is this solution right here. So this is our calculator output. Now again, for your calculator output, if you don't have that nice menu that talks about the list and the frequency and calculate, you need to make sure that you put in L1 after the command line. So let's go ahead and input our screen capture here. And this is where that input comes from. So this is our X bar as our sample mean. Okay, let's go ahead and look at number 2. Number 2 says to find the standard deviation for the given data. Round your answer to 1 or more decimal. So we're going to do the same thing here. We're going to go to Stat. Now here I want to make sure I clear my list. I'm going to clear my list differently this time just so you can see the different ways to do this. I need to input L1 here because that's the list I want to clear, and then hit enter. And then when we go back into Stats and edit, that should be blank, and you can see it is now. So we need to enter these values over here. I have 1, 2, 3, 4, 5, 6, 7 values to enter. So we have 53, 17, 35, 24 and 20. This is a shorter list. 44 and 68. And again, be really careful how you're entering. Take the time to go back and double check. So we're going to do the same thing again. Stat, Calc, 1 variable stats. Now again, if you don't get this menu, you just need to, after the word 1 variable stats, you need to input the list L1. I want to use L1, there's no frequency. Then we go down to calculate, and here's my output. Now from this output, this is where I want to pick my standard deviation. I believe it asks for. Let me try that again. It's kind of fuzzy. Okay, so from here it says find the standard deviation for the given data. Well, we have two different values here. We have S sub x. Now remember, S sub x is sample standard deviation. And then we also have sigma sub x, which is your population standard deviation. Now this is definitely a sample, so we want to find S sub x, the sample standard deviation. So that is going to be 18.83, which would be our value for D here, 18.8 rounded. Now one of the things to really remember is to always keep everything very accurate when you put them in the list, because it's easy to get off by a value. Okay, for our next one, it says the mean of a set of data. So that's x bar. So x bar is 273.02, and it says the standard deviation for the set of data is 108.22. It says find the z-score for a value of x equal 436.70. So our z-score is just z equal x minus x bar over s. Okay. And so from here we plug in those values. So our value of x is 436.70 minus x bar 273.02 all over 108.22. So what we want to look at here then is plugging this into your calculator to find out what the z-score is. Now the z-score gives the number of standard deviations we are above or below the mean. So let's go ahead and pop our calculator in. Now here we have to be careful about how we enter this. I need to go back to my main screen, so I'm going to go second and quit. And I'll put in 436.70 minus 273.02, and then divide that by the 108.22. Now it's important that you have the numerator in parentheses, so we make sure we divide by the entire difference. And we get a z-score then of about 1.51. We'll compare this with the possible values that they show us and see what answer we should pick. So it looks like for my value here of 1.51, that matches letter B. Okay, our next one is also finding z-scores, and we want to figure out whether the value is unusual. Now when we talk about unusual, that means it's plus or minus 2 times the standard deviation or 2 times the population standard deviation, either sigma or S. So when we're talking about this, we always have to start with that mean as well. So mean plus or minus 2 sigma. It says a weight of 232 pounds. So here's my weight, 232 pounds. I'm on a population having a mean, so it's a population mean. We're talking about mu here of 168, and then sigma, because again it's a population standard deviation of 25.8 pounds. So my z equals x minus mu over sigma. Now up here we were given sample information, so that's why we have x bar and s. Here we have population information, so we're using mu and sigma. So we have 232 minus 168 all over 25.8. Okay, so again, we're going to go ahead and plug that into our calculator. So we want to make sure we have our parentheses. 232 minus 168 divided by 25.8. So we have 2.48 for my number of standard deviations I am above the mean. Now, remember, usual and unusual, if we come back up to here, was anything more than 2 standard deviations. Well, this is 2.48, so we get z equals 2.48. This is unusual because it's more than 2 standard deviations above the mean. And that's what the z-score is counting, is the number of standard deviations above the mean. So let's go ahead and look at our options here. Definitely 2.5, so we could throw out this option and this one. Now I have to choose between these 2.5s, and I'm going to go that it is unusual because it's more than 2. So that would be letter A for 4. Okay, next one, it says determine which score corresponds to a higher relative position. Well, these are z-scores. So first of all, it says we have a score on a test. So we have test 1. And we have our score on this test was not x bar, but just x. We have x equal 257.4. And then we know that the mean of the exam for the whole class was 220. So it looks like we did pretty good. We're way above the mean. And the standard deviation is equal to 22. So my standard score here is x minus x bar over s. So we have 257.4 minus 220 all over 22. So let's go ahead and find our z-score then for test 1. So make sure again we have parentheses around that numerator, 257.4 minus 220, close parenthesis, divided by 22. So I get 1.7 here for my z-score. Okay, so that means for this one, I'm 1.7 standard deviations above the mean. So that's for test 1. Let's go ahead and do the same thing for test 2, and then we'll compare. So for test 2, I get an 89.6. But on this test, the average is 80. And the standard deviation is 8. So if we look at this, both of our averages, the 220 is higher than, our score of 257.4 is higher than the average of 220, and our score of 89.6 is higher than the average of 80. But what the question is asking is which one is higher overall relative to all other scores for that test. So we set up our formula, x minus x bar over s. So our x value is 89.6 minus 80 all over 8. So let's go ahead and plug this one into our calculator as well, and then we'll compare them. Again, we want those parentheses, 89.6 minus 80, close parenthesis, divided by 8. So it looks like we have a relative score of 1.2 for this second test. Now the question is, which score has a higher relative position? Well, 1.7 is higher, so that gives us our higher relative position. And this is when we had a score of the 257.4 on the exam. So the score of 257.4 has the higher relative position because 1.7 standard deviations above the mean is higher than 1.2 standard deviations above the mean. Okay, number 6 is a little bit tricky. We can use our calculators to help us with this a little bit, but it won't do the whole problem for us. So first of all, we're trying to find the percentile. Well, first of all, to find a percentile, I need to rank the data. So that means to put it in order. So I think the easiest, you could do it by hand, copy these down and cross them out as you go. But I think what I'd like to do is to just go ahead and enter these values to make sure I don't make a mistake. I'm going to clear my list. And then I will come down and start entering these 124, 136, etc. So I'm going to go ahead and hit pause while I enter all these values, and you go ahead and try the same on your calculator. Okay, I've entered all my values. Now you can see here 17, that's this blank line with the dots. So that would be the 17th line. That means I have 16 data points, and so just to double check here, if I count these real quick, 12, 13, 14, you have 16 data points, so it's good to double check that. Now to find the percentile, I need to order these. So the first thing we want to do is to go through and order these. So the command to order these is to go into stat. Now I have two options here. I have to sort A, which means ascending, that means getting larger, and sort descending, which means getting smaller. So I'm just going to go ahead and I'm going to sort descending just because my value of 130, which is the data point I'm looking for right here, is going to be toward the bigger numbers. So if I hit sort descending, that's going to help me find that value a little faster. So then I go to second L1 because it says I want to sort this list descending, and hit enter. Now I have to go back into my stat list and then go to edit, and then I'll see that it's sorted from the highest to the lowest value now. Now if I look at these values, 138, 136, 132, 130, there is the one that I'm looking for. So let's go ahead and pull this into our lecture, and we'll make a couple quick notes on here. So we're not going to see all 16 values here, but we know that in total, if I were to look at this whole list, there were 16. Now if I look from the top, I have 1, 2, 3. This is my fourth value from the top. So if you think about that, that must mean I have 12 values below. So I have 16 total values. I'm looking at number 130, which is the fourth one from the top, which means from the bottom it's the 12th. And 12 over 16 is 3/4, which is 75%. So it's the 75th percentile. Now if you wanted to, you could sort these from small to large and then count them all the way up to 12. But the problem with that is we get to number 13 and it gets a little bit confusing. So I'd have to think about 13, 14, 15, 16. There's 4 total values there. So I like this idea of kind of sorting it from the end that's a little bit closer, and then realizing this would be our 100% right here because it's the highest value. And then our lowest value, which would be further down, would be 0%. So this is the 75th percentile for that data point. Okay, number 7, it says to find the indicated probability. A die with 8 sides is rolled. So this is not a standard 6-sided dice. It has 8 sides. What is the probability of rolling a number less than 7? Okay, so probability of rolling a number less than 7, that would be a 1. I could roll a 2, and that's less than 7. I could roll a 3, a 4, a 5, and a 6. All of these are less than 7. Now the question is, do we include 7? And the answer is we do not include 7 because it says less than 7. It doesn't say less than or equal to 7 or at most 7. It says less than 7. So I would like to know the probability of rolling a 1. Well, I have 8 sides, and one of those sides has 1 on it, 1 dot, so that's the probability is 1/8. Now I have 8 sides. What's the probability of rolling a 2? Is also only 1 out of 8 because only one side of the die has 2 dots on it. Same way with the 3, only one side has 3 dots. Same way with the 4, only one side has 4 dots. Only one side of the 8 has 5 dots. And only one side of the 8 has 6 dots. So if we add these up, I have 1, 2, 3, 4, 5, 6. I have 6 out of 8, which reduces to 3/4. And that corresponds to our value here. Now if I wanted to, if I didn't want to add all of these up, I could also use the complement. Okay, it would be the same problem. So using the complement, I know my total is 1, and I would subtract off the probability of rolling a 7, subtract off the probability of rolling an 8. Now the reason why is, if you notice, I included 1 through 6. The only 2 that were left were 7 and 8, so that makes up the complement. So this would be 1 minus 1/8, because the probability of rolling a 7 is 1 out of the 8 sides. and the probability of rolling at 8 is also 1 out of the 8 sides. So this would be 1 minus 2 eighths, which would be 6 eighths reduced to 3/4. So I could also use the complement if you didn't like adding all these up. It's not too bad though. Okay, let's go ahead and look at number 8 next. First thing to do when we're looking at this table is to kind of section off the totals, because that'll help us look at these counts a little easier. So we have men and women, and we also have non-smoker, occasional, regular, and heavy smoker. So those are our categories. These are our totals, so everything is already totaled up for us. So they ask us to find the probability that is a man or a heavy smoker. So I'm going to use M for man, and of course we're using the word or here because it's given to us, and I'll use HS for heavy smoker. Well, our formula for A or B is going to be the probability of man plus the probability of heavy smoker minus the probability of both a man and a heavy smoker. So this is our quick little addition rule for probability. So looking on our table, the probability of being a male would be, this row would be 559 out of the 1129. Probability of a heavy smoker would be the total of this column, which is 71 out of 1129. And then we have to subtract the fact that we counted this 37 with the men and with the heavy smokers, so I have to subtract that out. Now that turns out to be the intersection, the and of men and heavy smokers. So this is that intersection that I end up subtracting out. So if we take 559 plus 71 minus 37, that brings us to 593 over 1129. And if we divide that out, we get 0.525 for our answer. And that corresponds to letter B. So we're just going right after our formula here. Now again, you can kind of logic your way through this from the table as well. Male or heavy smoker. So I need to count all the males, all the heavy smokers, and then I have to subtract out this 37 because it was counted twice. Okay, number 9. Okay, so for this problem it says we have a study conducted at a college shows that 63% of the school's graduates find a job in their chosen field. So this number looks important. Find the probability that among 6 randomly selected graduates, so this number looks to be my sample size n, at least one. Now this is important, this idea of at least one finds a job. Okay, so let's go ahead and start defining some variables. Let's let x equal the number who find a job. Okay, then from here we have the probability then that they find a job, and we're going to call this a success, so this would be our probability of a success, is 0.63. Okay, so if we know the success is 0.63, that also tells us that the failure then, the probability of those who don't find a job, is 0.37. So it looks like to me this is a nice binomial experiment. We know the number of trials in advance, so we know n is equal to, in this particular case, 6. We're going to check 6 graduates. We know that there's only 2 possible outcomes. They either find a job or they don't find a job. Whether one person finds a job or not is independent of the next person finding a job, and the probability of success is constant from trial to trial. So we have x is distributed binomially NP. Now for this particular case we know n and p. N is 6 and p is 0.63. So this is kind of all of our information that we have. Now the probability that we're asking for here is the probability of at least one. Finds a job. Okay, well this is going to be quite a bit of work, at least one. At least one would be 1 or more. So 1, 2, 3, 4, 5, and 6. So I'll have to find the probabilities for each of these. So this would be the probability x equal 1, plus the probability x equal 2, plus the probability x equal 3, plus the probability x equal 4 plus the probability x equal 5 plus the probability x equals 6. So I'm going to have to find the probability of all these or use the complement. So if you don't like the idea of the complement, you're just going to go through and find the probabilities, the binomial probability for each one of these and add them up. Now the complement, the sum of all probabilities is 1. And so what I do is I take 1 and I subtract out basically the only one I didn't count here. So if we ask 6 people, I have 1 found a job up through 6 found a job. The only one I don't have listed here is 0 finding a job. So that's the complement in this particular case. Now if I want to do this by hand, this would be the combination of 6 choose 0, 0.63 to the 0, 0.37 to the 6th. Okay, so let's go ahead and grab our calculator and let's figure out what that binomial probability is. I'm going to quit out of here. Okay, so for my combination I need a 6, and my combination key is under it's under math probability. And we can see our combination is the third one down here. So I'm going to have 6 choose 0. And I'm just going to do all these right away. And then I have 0.63 to the 0, which is just going to be 1. In fact, 6 choose 0 is also just 1. But I want to show all the steps here. And then I'll have 0.37 to the 6th. Enter. So I have 1 minus 0.0025657. 25657, and let's go ahead and subtract. And I get 0.997 as my probability, and that's right here. Now, if you don't like to use a formula, we can also use your calculator using the distribution function. So what we need to know are the values for n and p. Here they are, n and p. So I'm going to go to second distribution, and I'm going to scroll down to binomial PDF. Now, if you don't have this table on your calculator, you would still put them in the same order. So after binomial PDF and you have a parenthesis, you'd put in an n and a p and the value that you're looking for. Now for us, for trials, for this case, we have 6. The probability of success is 0.63. And then the value I'm looking for in this case is 0. Now if you wanted to do all of these, what you could do is set this up for each one and then add them all together. Okay, so here's my command. So if you have binomial PDF and you don't have that other shortcut screen, you'd put in n comma p comma your value of x. And if you notice, I still get that same 0.0025657. So my calculator output then would be 1 minus, and I guess we can go back through and show that again, distribution. We're going to go down to that binomial. And we want to make sure that we choose PDF. CDF means something different, so we want to make sure we choose that PDF. My number of trials is n, my probability of success is 0.63, and my x value is 0. And so now I'm taking 1 minus that value, and you can see I get the same answer. So let's go ahead and clip that and put it in our solutions, so we can see how easy that is to use the idea of the complement. Now if you don't use the idea of the complement, you're going to have to go through this binomial command 6 times. And what we'll do is we'll change this value from 0, and we'll start with 1 and then do it again plus up to the 2 all the way up to 6. So If you can see that the complement will work, it'll save you some time, but if you don't like the complement or if you're not sure about it, go ahead and just add all of these different binomial probabilities together to get the same answer. Okay, let's go ahead and look at number 10. Number 10 shows the table below the soft drink preferences of people in 3 different age groups. It says if one of these 255 subjects, so right now they tell us that our total here is 255. Not of each row or column, but the overall total in the table. Now we might want some totals for some of these rows or columns, but we don't know yet, so we'll just go ahead and read on. So out of this whole box, it says if one of the 255 subjects is randomly selected, find the probability that the person drinks root beer given that they are over 40. So this word given is very important. So the given basically means we have a conditional probability. So we have something like the probability of A given B. But what we have here is that the person drinks root beer, so I'm just going to use R for root beer, given that they are over 40. And I'm just going to put in 40 to help us remember that. I better put in greater than 40, I guess, to make sure we understand we're in this last row. Now, conditional probability, the probability of A given B is the probability of the joint, the R, all over the condition. The condition's always our denominator. Oops, and I think I've had my sign backward in here. That's greater than 40, over 40. So it's correct over here. So the condition is equal to the joint divided by the marginal. So if we look up on our table here, the probability of root beer and over 40, so here's root beer, here's over 40, and they intersect right here at 30. That's going to be my numerator. Let me write that so you can see the number. So this piece right here is the probability of root beer and over 40. Okay, now we need the probability of being over 40. Well, that's just the total, so I'd have 20 plus 30 is 50, 50 plus 35 is 85. So this is the probability of being over 40. So 30 divided by 85, and of course that's a fraction that will reduce, and we will reduce to 6 over 17. So that would be letter B for our solution here. Now you can kind of figure this out from the table without necessarily knowing the formula. So if we're conditioning on over 40, we're taking all 255 people and we're pretty much ignoring them all except those who are over 40, which is 85. So our denominator changes from that 255 just down to 85 because we're ignoring all other groups. We're just looking at the over 40s. Now in this column of over 40s, how many of them are root beer? And that's just this 30. So again, that 30 over 85, which is 6 over 17. So if you can remember to condition on that population, again, this nice little contingency table helps us find that probability very fast. Okay, number 11. It says we have the number of golf balls ordered by customers of a pro shop, and it has a probability distribution. So what this is saying is the probability that a customer will order 3 golf balls is about 14%. The probability that they'll order 6 golf balls is about 2%, 0.02. And what they would like us to do is to find the mean of the distribution. So we're finding the expected value or the mean. So the formula for this is to take each value times its corresponding probability and then to add them up. We also have a shortcut on our calculators that we can do. And basically, we are putting all of these values in L1 and all of these values in L2. And then we're using L2 as the weights. So let's go ahead and go to Stat and Edit. I'm going to go up and clear this list. And for L1, I'll put in the values of 3, 6, 9, 12, and 15. And then I need the corresponding probability. So across from the 3, I need to have the 0.14, and they have to go in the correct order. Make sure you get your decimals in there. Okay, so from here, what I can do is I can go then into stat. I'm still working with calc, one variable stats. And so L1 is my list, but my frequency is L2. Now for those of you who get just the one var stats on the screen, you would put in L1 comma L2. So yours will look a little bit different. And then we hit calculate. And so our mean is 9.84. That's what this is telling us. Now they don't give us a standard deviation of S. What they're giving us is standard deviation of our population sigma, because this is based on a long-term population of values. So that's kind of the difference here. So we get 9.84, which is letter D. So again, 9.84. Now if your screen doesn't give you the options of the frequency and you just have one var stats, you would do L1 comma L2 in the command and hit enter. Now if you do these by hand, I would take 3 times 0.14 plus 6 times 0.02 plus 9 times 0.36 plus 12 times 0.38 plus 15 times 0.1, and you'd run that through your calculator and you would get 9.84. Okay, so it doesn't matter if you use your calculator with the frequency list or you do it by hand, you'll get 9.84. It's probably a good idea to do both. Now this next problem is really the same thing in terms of entering the data, but what we want to do here is to find the variance, and so that's the difference. We're finding the variance. Now remember, the variance is not given on our output. The variance is sigma squared. So what I need to do is to find the standard deviation and to square it. Now there's a couple different formulas for this. We could look at the formula that did x minus mu quantity squared times the probability of x. So I'd have to find the mean first. So we take each observation, subtract the mean and square it, and then multiply the corresponding probability, and then go ahead and add those up for each row. Or you can go back in and use your stat menu and go to edit. And I want to clear both of these lists because I want to make sure I don't have any extra values in there. And for L1 I'd have 0.246, so 0.246. And for L2 I'd have 0.05, 0.17, 0.43, 0.35. Okay, so notice I have for each value on my L1, that's my X, and for P of X, that's my L2. So this is L1, and this is L2. Now we're going to do the same thing that we did last time. We're going to go to Stat, Calc. L1 is my X values. My frequency or my probabilities are in L2. And again, if your screen just says one var stats, you'll just put L1 comma L2, and your comma is right here below the sign function. So we have in our L1, L2, and hit enter. And we have kind of our answer. Not our whole answer yet, but kind of our answer. So let's go ahead and look at the output here. So this asks for the variance, don't forget. So this value of 1.689, etc., that's not our answer. They're giving you the temptation, though, to say that it is. This is wrong because this equals sigma. We want sigma squared. So what we need to do on our calculators, we need to take this value of 1.689, 496,967. We don't want to round, and we want to square this, so we want to take it to the second power. The reason we don't want to round is if we rounded this as, let's say, to 1.7, that would create a lot of rounding error up here, and we might get the wrong answer. So don't round till you get to your final calculation, and we get 2.854. Okay, so we need to remember when we're finding variance that we have to square the standard deviation, take it to the second power. So this is actually the variance. And that looks to be 2.85, which is option A. So be careful. You know, are you asked for variance or standard deviation? Okay, let's go and look at number 13. Number 13 is kind of like the insurance problem that we did in class. It says, suppose you pay $1 to roll a fair die with the understanding that you will get $3 back for rolling a 5 or a 1 and nothing otherwise. What is your expected value? Okay, so here I think it'd be a good idea to make a table. So in our table, we have x, and then we have the probability of that event happening, which would be p of x. Okay, so you pay $1 to roll a fair die, and if you win, you get $3 back. But if you lose, you just lose that $1. So there's a chance that I'm going to lose $1. Now this would be if I lose, and then over here I have if I win. Well, if I win, I get $3, but I spent $1 getting it, so I only overall net $2. So now we need to find the corresponding probabilities. So for the corresponding probabilities, they kind of give us a hint here. It says we're rolling a die, and we're looking for a 5 or a 1. So we win if we get a 5 or a 1. So if it's a 6-sided die, 2 of those sides will make a winner. So that would leave 4 of the sides to create a loser. And so this is my table again, just like we did in the previous two problems. This is my L1, this is my L2. Now this is expected value. So if you wanted to, you could also go after the formula x times the probability of the x occurring and then add them up. So that's a formula that we could use too. I'm going to go ahead and put these into my calculator. We're going to go to Edit. And again, I need to clear these. I want to make sure I don't have any extra values in there. So I don't have really much to enter here. I have a -1 and a 2. Kind of a short list. Now for my probabilities or my weights, if I want to reduce this to 2/3 and 1/3, you can. I'm just going to put them in as is, 4/6 and 2/6, because it kind of takes care of that for me in the decimal form. So now we want to go to Stat, Calc, one variable statistics, and again, list 1 are my values, list 2 are my weights. If you don't have this menu and you just have 1 bar stats, you'd put in L1, L2. And these are my values. This is not a very exciting game, because for this game it looks like in the long run, we're looking right here, my expected value is $0. So that would mean that whoever was sponsoring the game and paying out the $3 in the long run, they're not going to make money. And I guess on the counterpart of that, in the long run, you're not going to lose money or make money either. So it's kind of a zero-sum game here. Okay, let's go ahead and look at 14. Well, this one is nice. It says assume that a procedure yields a binomial distribution. Okay, so they're telling us right away. So x is distributed binomial, and then down here they tell us that n is 10 and p is 1/3. And they want us to find the probability that x equal 2. So if you wanted to do this with the calculation, you'd choose 10 combination 2, probability of success is 1/3 squared because I choose this value of 2. Failure would be 2/3 then, because it's a complement of 1/3, and this would be the 10 minus 2 or 8 power. So let's go ahead and plug this into our calculator and see what we get. Now for our combination, we start with the 10. Scoot this over a little bit. And our combination would be under Math, Probability, and that's the third option down here, combination. And we're choosing 2 out of there. And then I have 1 divided by 3 in parentheses, squared, because I want to square the 1 and the 3, not just the 3, so you don't want to put that in without the parentheses. Arrow down, and then I have 2/3, 2 divided by 3 in parentheses to the 8th. Okay, so go ahead and hit enter, and that looks like my probability. Let's go ahead and put that in to my calculations, and then we'll also use the binomial distribution as well. So it looks like to me we have 0.1951 is my probability. That corresponds to letter A here. Now there's another way to do this problem as well, and that is to use your distribution function, and that's right above the vars key. So we go second distribution, we'd scroll down to the binomial PDF, and what we have here is 10 for my number of trials. Now my P is the probability of success. They told us over here that that was 1/3, so we'd go 1 divided by 3 here. And then the X value that we're looking for is 2. So we'd hit paste, and it's calculating for us, and we get the same value. So if you don't have that shortcut option where they ask for the N in the trials, remember the order that it gives us is N, P, and then our value of X. So this is a shortcut. And remember, this is N, P, and then our value of X. So keep that in mind when you're looking at those. Okay, that's 14 and 15. Okay, so for 15, it looks like we're also kind of looking at a binomial distribution. So to see what our components are, first of all, it looks like we have our sample size of 30, so we have 30 trials known in advance, and we're talking about the number of defects. Now we will accept the batch if fewer than 3 are defective. Okay, now we talk about here is the probability in the long term of a defect is about 3%. So the probability of a defect is our probability of a success here, because that's what we're counting, and that's equal to 0.03. So the probability of a failure then is 0.97. So it looks like we've met all the criteria. There's 2 possible outcomes for each component. We either accept it or reject it. It's either defective or not defective. The probability of success is constant at 3%. We know the number of trials in advance that we're going to check, and if one product is defective or one component is defective, that's independent of the next one being defective. So let's go ahead and define some variables. X equals the number of defective components. So X is distributed binomially, NP, so that would be 30.03. Again, this is N and P. And so I want to know the probability of accepting the batch. And if we sample these 30 items and we get fewer than 3 that are defective. Okay, so fewer than 3. Fewer than 3 would be 0, 1, and 2. It says fewer than 3. I can't count 3 because that would mean I would say 3 or fewer. So this is just fewer than 3. So what I'm going to do here then is the probability that X equals 0, that would be 30 combination with 0, 0.03 to the 0, 0.97 to the 30, because it's 30 minus 0, plus combination 30, choose 1, 0.03 to the first, 0.97 to the 29th, plus 30 combination 2, 0.03 squared, 0.97 to the 28th, because 30 minus 2 is 28. Let's see if I can make that look like a 28. Now this is how you would do this longhand. Okay, and we also have a shortcut that we can use as well. But let's go ahead and do this one first, and then we'll look at the shortcut. Okay, so let's grab out our calculator. So we're going to start with our combination here, and I'm just going to put this whole thing in at one time. And that way I don't have to worry about rounding along the way or dropping too many values. So we'd start with 30, and then combinations are under math, probability. So 30, choose 0. And again, I'm putting in everything, 0.03 to the 0, which I know is 1, but I want to make sure I account for everything here. 0.97 to the 30th. Okay, plus. Okay, now I'm looking at my next term right here. I'm still going to do my combination, so 30 math, probability, combination, 1, 0.03 to the first. I'm using a first here because I'm right over here on this problem. Arrow out, and then I have 0.97 to the 29th. Okay, so now I have my third one, so I'm going to scoot this way, so I'm going to input this third one right here. So I have my combination, so I have 30, math, probability, combinations. This would be 2. So I have 0.03 squared, arrow out of there, 0.97 to the 28th. Okay, so I've basically put in this entire line in one shot. And let's go ahead and hit enter and see what we have. 0.9399 is what it looks like. Now we can't see the whole thing on the screen, but we can see the start of it in our answer. Okay, so if I put in this whole row, whoops, it looks like I need a parenthesis here. I don't have anything wrong, I just want to close that parenthesis. It looks like our solution here is 0.9399. So if we come up and look at here, I can see that that's letter D. Okay, so that's one way to do this problem. Now another way to do the same problem is to look at the binomial distribution on your calculator. So let's go ahead and clear this out, and we're going to go to second distribution. We'll go down to the binomial PDF. And remember, we don't want to choose CDF. That has different meaning. We just want to go to the binomial PDF. And then we choose our sample size is 30. So let's go ahead and put our 30. The probability of a defective component is 0.03. And we want to look at starting with 0, x value of 0. Go ahead and enter. And then I'm going to go ahead and do my other component, second distribution. I'm going to go to that binomial PDF. I still have 30 for my n, 0.03. Okay, but now I'm doing the one case right here. So I'm going to put in a 1. And paste, and then last but not least I'll put in my third value here, which is going to be my binomial distribution evaluated at 2. So that's second distribution. I want to go to my binomial PDF, not CDF, but PDF. CDF has a different meaning. It's a cumulative distribution function. And here I have my sample size, my probability of success, and now I'm going to evaluate this for 2. So I have all of these plugged in, and I go ahead and hit enter, and I get the same answer. So the distributions are usually a little less complicated to input. You don't have to worry so much about parentheses and everything. Okay, but it's also nice to be able to do these by hand to kind of understand where the numbers are coming from, and then you can also check them with your calculator. So this would be the shortcut using the distributions. Now the test that you're going to have is made up of 15 problems. The first 14 are multiple choice, worth 3 points each. The 15th problem is show your work. And so it's really important that you show your work as much as possible. So if you get anything wrong, you can still get partial credit. So writing this out would be important. Or if you're using your calculator, you could just write out these commands that you put in. You obviously can't copy and paste them because you have a paper and pencil test, but you could just write out the BINOM PDF parenthesis and then kind of just show that this is N, this is P, and this is X. And that would be a way that you could show your work on those as well. If you have any questions about the practice test, please let me know, and good luck studying for your exam. I hope you do well.